Hello, YouTubers. This is Group 1, the Beast Boys, doing Chapter 9, talking about creating the foundations of our deployment pipeline by Jeremiah, Eric, and Devin. You're welcome. We're going to be talking about the testing environment. Now, we can talk about the story of Enterprise Data Workhouse. They were a company working with 10 streams of different environments for testing. They had large groups, and it took too long for them to reach UAT. While they were deciding how to fix things, they tried using Agile for a year, which did not improve. Their workloads kept getting bigger, and they kept getting behind on their production goals. Only half of their source code matched what was running in production, meaning only half of their workload was actually making it to the next step. The reason behind all of this is because their test environment was different. Because each environment was different, whenever there was a deployment, there were fixes applied to that specific environment, and the changes weren't made back to the main version that was supposed to be deployed on everything. Every environment was different, every machine works differently from the other. So whenever they tested their code and tried to put it in production, there would be things they weren't anticipating in every environment. After reverse engineering the changes in all the environments, putting them all in version control and automating the process of their environment creation, they reduced time spent deploying from 8 weeks to 1 day. And all of this was done in the way we're going to explain to you today.
So with on-demand creation of dev, test, and production environments, developers run their own test environments on their own workstation. This helps with software releases because they're able to test their code as they're programming. One cause for chaotic, disruptive, and sometimes even catastrophic software releases is because we haven't seen the application used in a production-like environment. When the developers run their own test environments on their own workstations, this solves that problem. So, in addition to this, automating and creating a build mechanism for creating environments saves time. With automating test environments, there are various things that you can do to enable this. First, you want to copy a virtual environment, such as a VMware image or a Vagrant script, or boot an Amazon machine image file in EC2. You can also build an automated process that starts from bare metal, or in other words, you could do a PXE install from a baseline image. You can also use infrastructure code, configuration management tools, such as Puppet, Chef, is that pronounced Chef or Chef? I want to say Chef. Such as Puppet, Chef, Ansible, Salt, and CF Engine. There's also the use of automated OS configuration tools such as Solaris Jumpstart, Red Hat Kickstart, and Debian Preseed. You could also assemble an environment from virtual images or containers such as Vagrant or Docker. And last on the list is you could spin up a new environment in a public cloud such as Amazon Web Services, a private cloud, or other PaaS. With creating our single repository of truth, what you do is you create a version control system that records changes to files and sets of files stored with the system. This helps things to be more universal and more controlled, and then if everything is based on that, then you don't have the problem that was stated before where they had a bunch of different environments and couldn't track any. So it keeps track of revisions or commits and makes it easy to revert when it worked previously. The version control is available to everyone and enables everyone to repeatedly and reliably reproduce all components of the working software system. Following during catastrophe. Oh, okay. Okay. In the event of a catastrophe, the following can be checked. You can check application code and dependencies. You can check any scripts used to create database schemas, application reference data, etc. You can check all the environment creation tools used for automatic environment creation process, such as scripts, configuration files, project artifacts, cloud configuration files. You can check any file used to create containers, and you can check all supporting automated tests and any manual test scripts.
We need to be able to recreate the entire pre-production and build process, as well as recreate any previous state of the production environment. Sometimes this means that it's easier to rebuild and recreate than try to repair something that goes wrong. I like to compare this to like a house made out of Legos. Sometimes it's easier when that little house collapses in on itself instead of trying to pick up all the pieces and put all the Legos down exactly where they were, to just kind of tear apart what you had and restart from the beginning. Having repeatable environments creation systems allows us to avoid a catastrophic failure of irreproducible, I can't say that word today, irreproducible infrastructure. Any change made in an environment needs to be replicated everywhere else to ensure consistency between environments. These changes need to be made automatically. And to prevent uncontrolled variances, you can disable remote logins to production servers or routinely kill and replace production instances. Keep pre-production environments up to date to find problems at the earliest part of the life cycle. Now, this means that we kind of need to modify our definition of what done is. Done indicates that a code is integrated, tested, working, and potentially shippable, and demonstrated in a production-like environment. That means that it's going to work on like a virtual machine, even if it's not actually in production yet. You need to make sure that it's going to run in the same type of atmosphere that it's going to be in. It's important to make sure the environments from the version control are used in the daily work of development, so that we can have a clear expectation as to how it will behave in a production-like environment. The goal is to have frequent short development intervals, and having the code run in a production-like environment ensures successful integration in daily work. The more times code can be deployed and run in a production-like environment, the better. This gives confidence that most production development problems were found and fixed. The same tools used in pre-production should also be used in production as well. Deployment risk can be reduced as development and operations become familiar with how the code and environment interact, and practice developments early and often. So that's kind of our presentation, and in conclusion, it's important to have an easy way to create production-like environments on demand to reduce the risk of production problems later. Code is developed and tested in production-like environments thoroughly before determining that development on a task is done. By putting all production artifacts into version control, we can ensure all environments are consistent and repeatable.
This is for you, Sean. The man. Sean, the man.
The myth,
Nailed it.
the legend.
Awesome.